So guys, here we go. Quiet. Alright. So one of the things you guys noticed, that you guys came up with, right? There were several concepts that he got. What were those things? What were the things that he researched to make sure that the continental drift actually did happen? Nate, wake up. Guys, come on, you guys read through the web page. What information did you pull out of the web page? What evidence did he gather?
Rock formations.
Rock formations. Okay, good. We're looking for similar rock formations on both sides of the oceans. Okay, good. What else?
Animal fossils.
Animal fossils.
Plant fossils.
So animal and plant fossils. Okay, what else? There's one more. What was it? Looking for climate data. We're going to have a little surprising twist for you guys here at the end. Okay. So it's these three things as well as, I'm going to put out here, matching coastlines. So when I tell you what were the four pieces of evidence that Alfred Wegener used to prove continental drift, those are the four I'm looking for. Rock formations, matching coastlines, climate data, and animal and plant fossils. So I want to look at this in basically more detail. So if we go here to rock formations, one of the things that you guys will notice is that we have rocks from the Appalachian Mountains that match which country? Where do where do those mountains match?
Greenland and Europe.
Greenland and Europe. It's also right there on the board. Specifically in Europe, Scotland. In fact, there's small pieces of Scotland rock that are actually North American rock. And that were basically, when the divide happened, it kind of left those rocks behind and moved on. So it's kind of interesting that we had North American rock, but it's in Scotland. Okay. We also had very similar geology between South America and Africa, right? There's that big bend on the west edge of Africa. Basically, South America fits right in there with Brazil. So all those rocks do match up. So that's the first thing he did. By the way, guys, when he goes out and does this research, he's not doing research like what you guys would think of doing research. This is a lifetime of research. So he's spending decades developing this idea, looking for more evidence. Every time he goes on a new trip, he gets more evidence. And again, you're talking about the early 1900s. So travel takes forever. Even by steamship, to go across the ocean was a week's journey. So now start thinking about how long that would take. When you're gearing up for these expanses into dark continents that you haven't been to before, there's not really a lot of supply lines. It takes forever to get this stuff up and running. So he is taking a lifetime to do this research. All right, so that's the rocks that he's looking at. If we look at the animal fossils, three types of animals start to come out. We have the Kinemiriid, almost looks like a small little hippo, maybe a rhino. And we also have the Labyrinthodon, which is a very large lizard, almost like the, I would say a Komodo dragon, very, very large lizard. And then we have the Mesosaurus. What animal does the Mesosaurus look like? Brandon? An alligator. Now, do we have saltwater alligators or crocodiles? So it is possible that they swim in the ocean, right? But do the crocodiles swim across the ocean? No, they're still very close to shore. They're usually within maybe 1 or 3 miles of shore. So to find the Mesosaurus on both South America and Africa tells us that that species had to evolve at the same place at the same time. That you cannot expect this animal to cross the wide ocean. So at one point, they had to have been closer. Maybe not connected, but they definitely were a lot closer than they are today.
They could have swum because snakes nowadays swim from country to country.
No, they don't.
They get like shipped with like food and stuff. But that's
They
how I
get help
got
from
my
us.
snake.
They have in the continents they swim from place to place.
Well, yeah, they swim through the Nile or through the Amazon, and that's easily done. You know, that's short distances before you get to something new. You're talking about crossing a wide ocean. That's
They
not
have
going to
no
happen.
rest.
And even now, there are some cases where with the islands that you do get small lizards and stuff that can exist on the islands. But even then, you're talking about one or two that manage to occur with driftwood. It's not, and even then, those islands are awfully close to one another. So we don't expect it to be open across a very wide open ocean. So that's kind of the whole thing there. So he's looking at these animals, he's saying, okay, these are land-based animals, especially these two. These are land-based animals. They are not going to be swimming across the ocean. And again, we talk about Mesosaurus, it's definitely more of an alligator type of thing. So it does exist in the water. It does swim in the water, but it doesn't swim across wide open ocean. Just pay attention. But even more appealing is the concept of the plant fossil, which is Glossopteris. Okay? And if we look at this image, what type of plant of today does that look like?
Oh,
What?
oh, never mind. I wasn't
One of
even.
those fuzzy
Not the fuzzy, a fern. Okay, so Glossopteris is a fern. And when we look at, you can actually see this image in the book, and I know you saw it on the webpage, where the locations of these fossils have been found. The fern has been located on almost every single continent on the world except for Antarctica. Okay, so this is kind of interesting that we see all these fossils that again tell us that this thing isn't going to travel all over the world. So in order for that to happen, we have to have these continents much closer together than they are today. So it starts telling us that they must have drifted apart. Okay, that's why we call this continental drift, which is the beginning part of plate tectonics. It starts off with this concept of continental drift. One more thing that he did is he looked at ancient climates. I'm not sure if you guys know about this or not, but we have large coal deposits in Antarctica. In what environment does coal form?
Isn't it like
No,
swamps.
swamps. But not just any swamps. You need to have big swamps. All right? You need to have huge amounts of biomass that's going down to the bottom and just getting stuck.
Are they talking about
Okay.
Louisiana?
Exactly. So you almost need sub to full tropical. Slight suggestion here. Where's Antarctica today? And I'm pretty sure we've never been a completely unfrozen pole. So what does this tell us? And in order for coal to form, it needs to be done in a subtropical or a tropical environment. Therefore, Antarctica must have been much closer to the equator than it is today. So again, that's one of those pieces. And then another piece of evidence he found is that we do have glacial deposits in southern regions of South America, Africa, and even India. Now that's kind of the weird one. South America and Africa, I think you guys can understand that it kind of makes sense that we have glacial deposits. Because when we think about the Ice Age, we normally think of the Northern Hemisphere, and we're like, okay, yeah, we got ice coming down from the North Pole. But at the same time, while we have ice coming out from the North Pole, you also have ice coming up from the south. So it kind of makes sense that southern Africa and southern South America have glacial deposits. And even Australia is pretty close to the South Pole. But what we don't expect to see is glacial deposits in India, especially southern India. That's a long way to go for glaciers. Because you could say, well, maybe the glaciers are from the Himalayas. Well, yeah, you would expect glacier deposits up here in the northern parts of India, but not the southern parts of India.
Isn't Indiana pretty much in the same line as that?
No, not even close.
Well, I'm saying,
Indiana,
well, I'm saying like the United States, how we're so cold compared to them.
well, we're actually in the same line as Europe.
So why would theirs be colder? Just because of the hot islands?
Well, what do you mean there? Who?
Well, you're talking about having glaciers there in India.
Yeah. So we don't. There is glacial evidence in India, and it's not a place you would expect to find the glacial evidence.
So close to the equator.
Exactly. So that tells us that at one point it had to be much farther, either north or south. It's clearly not going north because of Asia, so therefore it must have been farther south.
No, it's much for that.
All right. So, but there's a problem. He has all this evidence, but there's one slight problem with this evidence. He's missing two things.
What made him move?
What made them move? He's got all the evidence that yes, this happened, but he couldn't come up with the mechanisms. What made the continents move, and how? So the two questions I want you guys to know. Why did Alfred Wegener's concept not work? He couldn't explain two things. Why they moved, how they moved. Okay, those are the two flaws with his theory. And that took many years to figure out, the how and the why. Okay? So what made them move, and how did they move? And that's the whole reason why his theory was not accepted.